Alright, so the next topic with percents is this other idea called percent change. And this pretty much gives you a percent from where you started. A percent of that will take you to where you need to go. So there's two parts to this. I try to keep it simple, so I use what's called new minus old. Now this small formula is called absolute change. It is just the difference between where you started and where you ended. Where you started would be old, where you ended would be new. Alright, if we want to do a percent change, the formula changes into a ratio where you have new minus old, and you're comparing it to out of the old price. And then you're going to, of course, multiply that by 100. Now I'm going to use this formula probably different than you've seen before. I'll do the basic setup, but then I'm going to use it for a lot of percent problems that you normally would not use this for. I just want to get you kind of used to it. So for instance, in this one, we have in 2010, ECC had a population of 3,500. In 2014, the population dropped to 2,600. And what is the percent change over these 4 years? So to set up the formula, I'm going to write it new minus old, and I'll change this as we go through it, over old times 100, and I want this equal to x. And again, this x in this connotation represents x percent, because you could always take that 100, divide it across, and you get x out of 100. So it literally just means x percent. Alright, in this case, the new value is the one that happens recently in 2014. So the new value is 2,600. So you get 2,600 minus the old value, which happened in 2010, of 3,500. And you're going to divide by the old value, which is 3,500. Well, this is going to be a bad parsing, so bear with it. So we have the new minus the old over the old, and make sure that these two numbers are always exactly the same, because they are literally both old and old. Alright, we're going to turn around and multiply by 100, and this should give us our percent, our x percent, or our percent change. Alright, now one thing that's kind of important is you want to find the absolute change first in your calculator so you get the right answer. If you try to type this all into your calculator at once, you're going to get some weird number that doesn't make any sense. So make sure you do the new minus old in your calculator first. So 2,600 minus 3,500 for a grand total of negative 900. Then turn around, I'll write it down, but I usually don't, and divide it by 3,500 and multiply by 100. So divide that by 3,500, multiply by 100 for a grand total of negative 25.7, and don't forget that this is a percent change. Now the negative in this case has words associated with it. If you're typing it into Moodle though, you need to put the negative and the percent. If it was a written test, this would be 25.7% decrease in value. But for Moodle's sake, online sake, this is the answer. Now this is a problem to find the cost after tax, or an increase in value, or a markup cost. So anytime you're doing a percent increase on something, you could use the percent change formula. Now, for this type of problem, I generally wouldn't use that formula, but because I want to concentrate on this formula, I'm going to use it in this case. So the percent change formula, new minus old over old, times 100. And I also want to get you used to thinking of percents as positive percents and negative percents. So in this case, excuse me, we're talking about an 8% sales tax on something of $300. So $300 is a fixed value. It's either the new or the old. And then this 8% sales tax is going to tell us what kind of number is going to go over here. So by the formula, we just write X, and we know that this thing is, a percent. So let's plug in what we know. Do I know the new value? That would be the cost after tax, and the answer to that is, well, no. So I'll put that down here. Do I know the old value? Well, the old value is how much it costs on the shelf, not how much it costs when you're buying it. So that would go here. Since it's the old value, it would also go in the bottom. And then times 100. And when I get it over to the other side, it's a sales tax, so it's an increase. So I'm going to write a positive 8%. Now the plus isn't important, but you have to think about what its sign is. For some of these later formulas are going to have to work with. Alright, so to solve this, what would you get rid of first? Well, one of the things that I would get rid of first is this 100 to make this 8 truly a decimal form. So you can write new over and over again, or you can just write X or N. Get used to the capital N. So N minus 300 over 100. And what we're going to do to get rid of that 100 there is we're going to divide both sides of the equation by 100. Now when you divide both sides, it has nothing to do with this piece because this is all multiplication. If you divide, it just cancels the 100s here. It doesn't affect this part over here. Alright, so this will equal 0.08. Oops, that's supposed to be a 300 down here. There we go. Alright, to solve this, we have to get rid of that 300 in the denominator. So you'd multiply both sides by 300. And the 300s are going to cancel. And you are left with n minus 300 is equal to 0.08 times 300. 24. And then the last step is to get n by itself, so you would add 300 to both sides and end up with our final answer, which is the new value is going to equal $324. So after tax on $300 of 8%, we will now be paying out $324. Now the reason I wanted to go through this mess is to show you the other way of doing this. So if you look at this the right way, here the first thing you did was change your percent into a decimal. So percent to deci. And that was step number 1. Alright, step number 2 is to take your decimal value and multiply it by your old amount. So this would be decimal times old. And that would be step number 2. And then down here, you're just adding back the original price. So this would be old plus the decimal value you came up with of the percent times old. And that would be step number 3. And this is actually the quicker way of finding out a tax. You take your old, you add on the decimal value times your old. So in this language, it becomes 300, or with these numbers, plus the decimal value. Alright, to pick up where I left off. So we had the formula old plus deci times old. And this would be your new value. So the old value, if we're going to use the numbers that were here, would have been $300. The decimal value of the percent was 0.08. The old value again was $300. And if you type that into your calculator exactly the way it looks, it would have gave you the answer of $324. So this would be the short way of finding the tax value, or the item value after tax. Okay. We can do the same thing for sales. And what's important with sales is how we treat the percentage. So we would set up our formula, new minus old over old. We would multiply by 100, and this would give us our x, which is in terms of a percent. Alright, so you plug in what we know. Do I know the new value? Using a percent change, find the sale price of a $150 jacket. Well, I don't know the new value because this is the original cost of the jacket, and we're taking a 35% off of that. So the new value becomes our variable n. The old value is how much the jacket originally cost, so 150. We would multiply that by that 100. And when we write the percent this time, we have to be careful. Remember, this is percent change formula. And if we're doing 30%, 35% off, that means we're removing part of the value, so it becomes a percent decrease. So we would write it as negative 35. And that's probably the biggest stepping stone, is to know when it's positive and when it's negative for our future formula. Alright, so we'd go through the same process of solving this. We need to get rid of that 100. Might as well change the percent into its proper decimal format. So divide both sides by 100. That leaves you with n minus 150 divided by 150 is equal to negative 0.35, or just 0.35. But still keep that negative with it. That's important. Then we need to get rid of the number in the denominator, so multiply both sides by 150. And that becomes, well, the 150s will cancel. You get n minus 150 is equal to 35% of 150, which is 5250. But it's going to stay negative, so this becomes negative 5250. And then the last step, of course, add that 150 across. Now when we add this 150, because they're going to be opposite signs, we're subtracting these two numbers. So the final answer will be 150 minus 5250. So let's see, 150 minus 5250 for a grand total of 9750. Now, because it's money, I'm going to round it to the tenths, hundredths place. And then don't forget, this is dollars. So the original cost of the jacket was 150. The new cost of the jacket after the sale is less, 97.50. Alright, but there is also a shortcut to this one. So you kind of look at it as, what happened here with number 1? Well, you took 35% and changed it into its decimal form, 0.35. What happened in number 2 is you took that decimal value and you multiplied by the cost of the jacket. Now remember, it's a negative decimal value, so this would be a negative value. And number 3, you added back the cost of the jacket. So the way this works is you would have your decimal value. Oops, spelled it wrong, even for my abbreviation. You'd have your decimal value, which is this one. You'd multiply by your old cost, which is the 150. And the deci value was negative to begin with. In the last step here, number 3, you would add on your price of your old. Now, if you put plus old over here, you can switch them because of the commutative property, as long as you keep the sign positive. Alright, so in this case, if you wanted to use the shortcut formula, you would, the old value is 150. It would be minus, because it's a discount, the decimal value of 35% is 0.35, and then you'd multiply by 150. And then type it in your calculator, and you would end up with $97.50. I mean, it's much quicker, but it makes more sense after seeing it processed with a formula that we know that works. and then just picking out of it what pieces we need to come up with a shortcut. But again, I want you to get used to this because the next formula is going to be a little trickier.